autorização, ou se você tivesse sua navegação filtrada por causa de interesses comerciais. A liberdade de expressão, a privacidade e a neutralidade da rede são fundamentais para a internet. E esses são apenas alguns dos 10 princípios formulados pelo Comitê Gestor da Internet no Brasil. O CGI.br promove há mais de 20 anos a internet no país. Graças a ele, você tem constante inovação, segurança e diretrizes para o desenvolvimento da internet. Isso tudo é feito de forma colaborativa, transparente e democrática. O comitê é formado por representantes de todos os setores da sociedade. Assim, as decisões são tomadas por meio do diálogo, com a participação de todos os membros até que um consenso seja alcançado. Por esses e outros fatores, o modelo brasileiro de governança se tornou referência no mundo todo. CGI.br, por uma internet cada vez melhor no Brasil.
Quando você registra um domínio .br, você está contribuindo para a melhoria da internet no Brasil. Pois cada domínio que usa o .br é registrado pelo NIC.br, o Núcleo de Informação e Coordenação do .br, que além de registros de nomes de domínios, investe em análise e tratamento de incidentes de segurança, projetos de tecnologias de redes e operações, pesquisas que trazem indicadores sobre o uso das tecnologias da informação e comunicação, implementação de pontos de troca de tráfego local na internet, projetos que contribuem no desenvolvimento global da web e muito mais. Tudo isso porque o NIC.br é uma entidade civil de direito privado e sem fins lucrativos, que mantém uma estrutura de registro de domínio segura, estável e de confiança, e reverte parte do que você paga pelo seu domínio no desenvolvimento de infraestrutura, trazendo benefícios para todos que usam a internet no Brasil. Toda essa inovação, tecnologia de ponta, segurança e infraestrutura só é possível porque você tem um domínio .br. NIC.br, sempre em busca do melhor para a nossa internet.
Bom dia, pessoal. Sejam
Good
muito
morning. Welcome to our second day IX Forum 17. Once again, I would like to thank our sponsors, Ed Uno, Vital, Select, Technology, WZTech, Networks, NTT, Elea Digital, Flex Optics, UPX, Equinix, and our silver sponsors, Accent, Nokia, BR Digital, IPS Global, KP2 Telecom, CDN Star Global, Siena, Netflix, OpenX, Current, Pier 1, Seaborn, Zap Telecom, Abranet, Padtech, Hurricane Electrics, and Logicalis. Thank you so much to all sponsors for all your support. Thanks to you, we were able to put together our 17th edition. Next, we have 2 videos of our sponsors.
A Select é o parceiro ideal para o seu provedor. Nós somos canal VAP Huawei e nós já atendemos mais de 5.000 clientes no Brasil todo. Huawei, Uni, Sumec, Houston, Roku, tudo aqui disponível para você crescer a sua rede. E quando você faz o cadastro na Select, você tem acesso ao nosso produto de locação. Você pode adquirir todos esses equipamentos em 36 vezes, sem pagar de FAO. Então não perca mais tempo. Clique no link abaixo, fale com os nossos consultores, acesse R$1 milhão da Select para o crescimento do seu provedor. Como eu sempre falo, vem para a Select.
Aos patrocinadores novamente.
To our sponsors, thank you so much once again. Okay, now Rodrigo Regis and Antonio Moreiras from NIC.br. Could you please give us a report about OpenCDN? Let me remind you that we are going to start the silence mode presentation, so you all need to use your headsets right now.
Olá, bom dia, pessoal. Algum santista aqui? Não, né?
Good morning. How are you all doing?
Bom, a ideia, né, como o Galvão acabou de apresentar, a gente fazer report aí.
So the goal here today is to give you a report about the OpenCDN. For those of you who haven't heard enough about the program, I'm gonna give you some details and give an update about future perspectives for the coming year. Hi there, good morning. I'll give you an overview about the CDN project. OpenCDN is an infrastructure sharing project. Despite the name OpenCDN, that is not quite a CDN. We do not provide CDN infrastructure, but rather a basic infrastructure for those existing CDNs to install themselves in the NIC.br Internet Exchange, where they are not yet available by themselves, where it's not yet attractive for them to be there by themselves. For instance, Salvador, which was our pilot project. In Salvador, there were just a few CDNs. So we got a data center, an autonomous system. We participated at the OpenCDN, IX. We take part as any regular participant, and we invite the CDNs, any other Meta CDNs, and we ask them if they want to have their cache there. We want this infrastructure available, so please that cache as if that would be a provider one, and we are going to offer you a access possibility throughout our point of traffic. And once that we have to afford some costs with the data center and with the caches, we share costs with participants. That's not available costs, we don't have costs everywhere. For instance, we might have a site where we don't have to afford a data center costs or no link to feed the caches thanks to our partnership. So in some sites today, we still do not share costs. So participants, they don't have to afford anything yet. But later on, once that project becomes much larger, those costs will be shared. So from a CDN perspective, if there is anyone here today with no caches yet, we may offer you a way to host your CDN and a link to feed your cache. And for providers who participate at the internet exchange point, we offer you a possibility to reach that content. That might not be the cheapest way. There might be that in a place you will find a great offer to a link to use in São Paulo that might be cheaper than getting to a place where you're going to exchange traffic locally. But the quality of the service is going to be better due to the proximity or the little delay or redundancy. Providers, ISPs, they connect themselves in another state, let's say Bahia. So I just got Bahia as an example because we started our project in Salvador, but we have some other sites such as Recife, Brasília, Manaus, and ISPs, they are from nearby cities. They do not connect to local IXPs, and there is nothing wrong about that because the content, they have much it's very possible to exchange content in São Paulo, and that's not a problem. You can do that as a complementary technical aspect. From a quality perspective, you would exchange traffic also with your local providers, and content should be present locally. OpenCDN tries to speed up content to be locally present, and also that drives attraction to local providers. Content, they cannot be released if there are no providers and vice versa. So we try to solve that. OpenCDN is a structure project as well as NIC.br. It helps to organize Brazilian internet infrastructure. The whole traffic internet exchange should not just be concentrated on a hub such as São Paulo and Rio de Janeiro. We could foster a decentralized internet exchange point considering the large continental dimensions of Brazil. So IXP, with all different sites that we have, a total of what? 35, 36 sites that can be very helpful. And CDN supports and speeds up content presence at different sites. One final comment before I hand over to Rodrigo. Our time is almost up, and I didn't let Rodrigo talk yet. Some home tech message to providers. Yesterday, I heard people saying, come on, what's taking place at city X with the traffic? I invested, I have caches over there, and there are no participants. People from the city of Belo Horizonte, they were complaining about that. And that is a city where we do not charge anything for an open CDN. That is free of charge, and we don't have enough IXP connected, taking the best or benefiting from get that content free of charge, at least from our side. Now, providers will have to pay a certain amount to reach the IXP. So I made an investment and you are not, helping at all. Well, guys, if you agree with me, so please support us and participate. Okay, then, today we are present at 5 different sites. Salvador was the first place. We started there with our pilot project back in 2018. We have Asian, Akamai, Google, Global, Microsoft, and Netflix caches. In Manaus and Amazon region, we are there since 2020 with Akamai, Codeflare, Google, Global, and Netflix. Brasilia since 2021 with Cloudflare, Google, and Netflix. And the two most recent ones are Recife and Belo Horizonte. In Recife, we just have Netflix, and in Belo Horizonte, CDN TV, Google, and Netflix. There are some partnerships at some sites where we can count on the collaboration of some local providers, such as RNP, which always collaborates not only in Salvador, but with the smart hands-on. They supply a mix for cache guidance. Serpro, they supply rack space in Brasilia. Bemol Store, they give us a support in Manaus, Century Telecom for internet support, and in Recife, they, support us with accommodation and so on. On the right of the slide, you can see the size of OpenCDN impact. I took as an example Salvador City and Manaus. The peak of local IXP was around 20 gigabytes per second. Today, that has reached 200 giga per second. Half of that is OpenCDN, and the rest participants and local providers that understood the importance of the project, and they understood they could benefit from the local OpenCDN. And with OpenCDN, the traffic as a whole has increased. In Manaus, they had 3 giga IXP per second. Today, we have reached 40 gigas per second. A summary of our activities. Today, the OpenCDN team is quite small. Moreiras, myself, and Daniel. We just started the project in Recife and Belo Horizonte last February, and we have activated CDN at some other regions, such as Brasilia, Manaus. In Belo Horizonte, we started activating CDN TV, Manaus Cloudflare, and a month ago, we had uploaded a Microsoft cache in Salvador. Some figures. How did OpenCDN impact our different regions? How many ASNs are we connected to? And how many ASNs are we serving indirectly? I mean, clients who are direct customers of OpenCDN. Just for your knowledge, Salvador has 120 giga IXPs. Manaus is doing around 30 to 40 IXPs. As Moreira said, in Recife and Belo Horizonte, those two last sites, they are still open in the ATM. There is no need to open activation tickets with us. Everyone in the ATM is able to get content. There are some specificities with Netflix, which I will share in a while, but yet IXP rate is still very low in those two regions. So we have a total of 300 direct ASNs and over 11,000 ASNs, which are served indirectly. Salvador is our preferred hub. Here, one of the CDNs in Salvador, which will illustrate a breakage of a submarine cable which links Salvador to São Paulo. Many Salvador autonomous systems, they are connected and they had their optical fiber interrupted, and they decided to cross to OpenCDN, which had fourfold during this period of time. And the traffic also has increased threefold higher. Some curiosities that we should highlight. First, the importance of OpenCDN. OpenCDN has helped to support the resilience of the network in Salvador. After the rupture of a submarine cable, OpenCDN was able to overcome such a requirement. More recently, in the WTR, I try to understand how come that participants that are already in the OpenCDN and IXP Salvador, they would come to São Paulo instead of exchanging directly in the OpenCDN. They just moved to the OpenCDN effectively when that optical fiber has been ruptured. Well, just a side comment. As any operation, if there is scalability, we are able to look after costs. In Salvador, we managed to reduce costs as we hire Link to feed CDN caches. If I contract 1 giga, 10 or 100, the price that I will pay per mega, it's going to be different. So the more people participating at OpenCDN, the better to be able to reach cost reductions. One of the CDNs in Salvador, which is our first pilot project, they haven't done it yet, but they will probably do it soon. They are not happy. No, it's exactly the opposite.
So the first time you reach the goal of OpenCDN, they leave OpenCDN, and then he puts up his own infrastructure on Salvador's PPT, because before they didn't consider it to have enough traffic or providers. So OpenCDN provided conditions for them to grow sufficiently, and then CDN saw how attractive that was, and so it decided to invest on its own. We would like all the others to do the same thing. So we'd go from Salvador to other cities, and this can be done at some point in the future. As I mentioned, there's one point about Netflix content consumption, the way it is consumed. So unlike when they're directly on ADM, to get Netflix content on OpenCDN, you need first to be accepted. So we just announced prefixes, the ones you want to be passed on to Netflix. So you announced these prefixes with a commute GDP that's 427,40,000. That's the BGP. So we just deliver content for those that announce prefixes with this community mark. Why seek content, not only Netflix, but any other CDN on Open CDN, even if you have some of these caches in your infrastructure or in your traffic provider or any other PPT you're connected to. So there's quality, as mentioned before. CDNs choose to provide traffic in the caches that are closest to their customers. And in this example of Netflix, the caches that are an open CDN, they have 100% of Netflix catalog. And some smaller providers don't have the full catalog. So we had participants in OpenCDN that have Netflix cache in their infrastructure, but they sought 20% of that content on OpenCDN. Another important point is the quality of the streaming that is being provided. The higher the quality, of course, the higher the resolution of the video you're seeking, right, on Netflix. So rather than providing 4K content, if you're in Manaus or in Salvador, if you need to provide 4K content, seeking it in São Paulo or locally, of course, those that seek it locally will prevail, right, when they seek it through OpenCDN. Then we have some other details. We'll have more presentations about Netflix, and they'll give you more details about their cache and how the community can be used. Now, 2024. There's some project issues here. In the first half of the year, we're expecting to install a new CDN in Manaus. You just need to correct, it was in capital letters. Yeah, that was a typo, yeah. So new locations, new sites, Belém, Cuiabá. On these sites, we will provide a full open CDN structure with a cache hosting. So will be or there will be 2x participants, and then some other sites we will try a new type, and that's the remote open CDN. What's the idea behind the remote structure? In Feira de Santana, Caruaru, João Pessoa, Maceió, and Goiânia, the idea is not to have the full open CDN infrastructure, but rather get content from the closest CDN. So we can serve more than one site using a single open CDN structure. As a result, cost will be lower because we will have more participants in this, and the splitting, if you will, of all expenses. So we will try these models remotely because these are about places that are close to each other. Goiânia and Brasília, Salvador and Feira de Santana. And one more thing before we finish. One thing we're expecting to do in 2024 is to use OpenCDN to encourage the implementation of IPv6. We are still in the process of approving the budget for this, but things are on a good track. That's not a promise, it's an almost a promise, a quasi-promise, if you will. So we are getting incentives to the cost of traffic of IPv6, almost zero IPv6 for participants on OpenCDN. So you go to Google's or Netflix's cache. So whatever your traffic in IPv6 is, NIC.br will pay for it. In other words, customers or clients will not need to pay. And that's the data center and link cost. So we will foot this bill for you. All right, that's it. So we're here at your disposal. If you have any suggestions, any questions, we are we're not allowed to ask questions, I believe, because we're running out of time. Will Galvão let us do this or no? Well, look at the way he's laughing. I don't think we'll be allowed to ask to have our Q&A session. Yeah. All right. Let me just try to explain that chart where we had submarine fiber for Salvador and Rio. Maybe you shouldn't put the blame on the providers. Maybe a provider is not set up in a way that they can use OpenCDN as a priority. So what you get from CDNs, to use Global's nomenclature, they prefer the tier 0 that is in São Paulo, and OpenCDN for them is considered tier 1. So maybe you could recommend these providers that, although they have a direct link with the São Paulo X, they maybe should have some pretend. So if you need to choose a CDN, the traffic should be prioritized locally. In this case of Salvador, for instance, or rather than the São Paulo one if you're in Salvador. Well, Pedro, we have such cases where we have prioritization problems. So we try to contact the provider team and solve the problem. This case that we had in Salvador was different. This was not an OpenCDN participant. He was part of the PPT, but he didn't opt for OpenCDN. So we have some former OpenCDN participants that wanted to reactivate their participation, and also the case of many non-OpenCDN participants that were requesting to be OpenCDN participants. So we try to serve everyone. There was also an increase of participants that fit into this example you've just given. So you're not wrong. No, it did happen too. All right. Thank you, Rodrigo. And you will stay, right? Moreiras, you stay. Rodrigo leaves. So Moreiras and Eduardo Morales will now present a report and the data of the Acelera net and capacity building. Eduardo, you have the floor. As I said yesterday, in our opinion, having these reports of other projects extremely interesting for this conference, because both OpenCDN and these capacity building initiatives that we hold, although they're managed as separate projects on NIC.br, it has everything to do with XBR in our opinion. They're complementary. So these capacity building projects that started back to 2008, we saw at the time the need for XBR participants to be better trained technically, as we saw that they were having difficulty in their daily settings, activation, operations. That's why this project was conceived. The idea, of course, evolved over time, and I'll let Eduardo tell us what we did and what we are doing now. Thank you, Moreiras. Yeah, the project evolved over time. It's been evolving. We had podcasts, for instance. You can listen to things like about the internet, its infrastructure, its technology. And this podcast project started in 2020. This was one of the children of the pandemic, right? Everyone started to work remotely. So we needed to serve the needs of the community, providing technical knowledge. That's why we conceived this monthly podcast. You're the host, so you know about it, right? And we have 44 episodes now. Some were special episodes, in addition to the monthly episodes, and we have over 62,000 reproductions we've been heard or listened to from in over 20 countries, and we are on the top 11 on Spotify in the technology section. We're really proud to disseminate this knowledge through our podcast. I'd like to ask for your help to listen to our podcast and sign our platform. We try to provide knowledge in a simpler way than in our capacity building, our training sessions. Being a bit more playful, talking about quantum computing or underwater or submarine cables. We have some experts that are not that common, like Army experts discussing, network infrastructure, security, and even career. If you want to work, for the Army, what is required if you want to join the Army or at some other point in your career, you could join the Army. So we talk to experts, even the Kamada Oito team. We're always discussing topics that are relevant to the technical community. So we have the QR code, you can subscribe to our podcast. Yeah, you can look again for podcast for it on your podcast providers. Yeah, next Wednesday on the 13th, we'll have our last episode this year. I hope you like it. You can also provide suggestions, right, for topics for us to discuss. Just send us on Spotify. Can we give them a spoiler? Well, Moreiras, you tell me. Am I authorized to give them a spoiler? We are recording episodes here too. Yesterday, we recorded 3. Yes, and we'll be recording more on a wide range of topics. Some episodes talk about a person's career. Yesterday, for instance, a spoiler, we recorded one with Wagner Maya. I don't know when it will be posted. We'll have also podcasts discussing technology. Don't tell them everything, please. Try to hold it. We talked to someone from a CDN, and that will be really interesting. And there's one that will be a bit heavy, technically speaking. I don't like spoilers. Okay. So next week, we'll be launching it. And I'd like you to listen to them, to these podcasts. We try to make this not just temporal. I mean, you can learn everything. We're not discussing on things that are too instant, right? We try to provide knowledge that is more perennial. And then we have projects with BCOM. That's the regional X forums. So we had 5 teams where this is provided. Again, it's distance education. We have face-to-face with 45 people. Now, of course, we are much more present when it's a distance course with 80 people. We use the metaverse to teach people. So you have a little figure there. We try to encourage our students to talk to each other and to discuss points with each other, unlike other teaching methodologies in which people just watch video classes. We prefer interaction between students. This is something we wanted to make sure was provided in our distance courses too. Then we have IPv6 face-to-face courses too, with 3 groups. So we had these 3 groups. Now the distance course, you do it, of course, at your own time. We had over 3,717 students that were graduated in our distance modality, so students can take these classes and learn about IPv6. We're hoping you can use IPv6. We would love to no longer need it, of course, but we see professors, university professors using it in university courses. Yes, many professors ask their students to do this distance education course, and then at the end of the course show that they completed the course successfully and passed all the examinations. And this is used as one of the courses for like a semester, midterm assignment or something like that. And network professors that don't do this yet, this is a great tip. There's one thing that you won't need to do. Just let students do the course, and then they just take a screenshot of the final screen, like the one with the certificate. Yes, because this distance courses, they're not only about watching videos, they have examinations and work assignments to do. Yeah, we have some partnerships too with Cisco, Metacat. We have 3 CCNA modules. We have also introduction to cybersecurity courses or essential cybersecurity introduction to the Internet of Things. We also have a partnership with Ubiquity. So we have a radio frequency or Wi-Fi course. So we work together to provide this course, and we want to do it next year too. So we are seeking partnerships to try to disseminate knowledge. We want to teach Brazilians the technical community so that we have a better internet for everyone. We also have a program of lives that's called the Intra-Rede program or Internetwork. And this is about topics related to infrastructure. We have a roundtable. We invite professionals to, again, share their knowledge. It's more of an introduction type. They have about 15 to 20 minutes to speak. And those that are watching, they can interact with those experts and ask their questions, clarify their doubt, everything that is involved with these professionals, and learn more. This is also a child of the pandemic. It started in 2020. It's almost every 2 months. So we've had 28 episodes during the pandemic, of course. We had more than one every 2 months. So we produced 4 episodes. Now we're trying to do this every 2 months. Anyway, the total is 28 episodes so far. The slides will be on the website later, okay? So don't worry about this. You just go to these links and watch these video classes. And this is also a request for you to register in NIC.br's YouTube channel, where we have our lives. If you subscribe to our channel, you'll get notifications of the next lives, and it's easy when some new content will be aired. We're talking about the future of provider market, and also where standards come from. And this is about the Internet of the Internet, where we created IPv6, where 5G is being developed. And we've had, again, one about the 25 years of progress in IPv6 infrastructure. We talk also about security tools that administrators should know how to build a data center that meets your company needs, and also different certifications. That was the last slide that we did in November about how to improve the curriculum of network professionals.
Those of you who'd like, you can watch our prior lives. All lives, they come with their time in their description. So let's suppose that you just would like to watch one of the presentations, a specific one, so you can just follow, the minutes of that presentation. And people usually, they complain about that. When will Moreiras stop talking and get straight to the content? So for those of you that will watch the recorded live, just, click and play whatever you are interested in listening to. So once we realize that there is enough number of people, then we, hand over the floor to the speaker. So use the minutes. We could also, time this talk. And there is another program, which is a capacity building week with the small courses, quick courses. One day you have Portuguese, another one math, where as if you were in the high school. So for a week, we discuss one technical tutorial, which is addressed by an expert. So we record video classes, we broadcast a recording, and we ask the teacher to interact in the YouTube chat with their students. We know that there are over 1,000 students participating, and if there is anyone with some, questions, the teacher is there to solve their questions. We work with the theoretical things, practical. We are on our 7th edition, and in our first semester, we have talked about flow, the journey of protecting your network, monitoring assets, and CGNet. How can we talk about CGNet? And we are promoting IPv6. Yeah, we better speed up. We are running late here. This is our 7th edition, talking about DNS, how to set it up, and how to do that with the DNSSEC, how it works. We have also addressed troubleshooting to network developers, how to request and activate ix.br. So watch that before you start setting it up. It will save you time, and analyst time will be saved. And the next, NGINX. Citizen in the network, where we try to disseminate knowledge to regular users, where we have videos, 15 minutes animation, where we want to add digital knowledge.
Só o conhecimento técnico, mas agora a gente quer entrar nas ferramentas.
We want to work with mini tutorials. There is a need for regular users to know how to do that in their smartphone or desktop. We are going to do those mini tutorials, and we are trying to produce them on a vertical position. So take a look at the videos on YouTube, but you may customize the video with your logo, and you may apply that as a provider's tool to educate your clients to be a supporter of that initiative. While you download the videos, that will come with your video, with your logo, I mean. Universities, providers, academy, several institutions supporting with no cost, zero cost. Just send your logo in the right format. You are able to download and up that load in your WhatsApp group, and you have that available to your users, to your clients, being internal clients or external. We have reached over 100 videos to download. The last ones, they were referring to Black Friday. And this event is being broadcasted in Spanish and English. Almost all videos are being translated to Spanish and English. And this year we have a new program called Acelera Net, where we wanted to bring knowledge to companies by educating their employers, their employees, to improve their career thanks to a certificate. They will undergo a test. The average score is 7 to pass the test. We have the basic formation of ASPs, one course per day, one IPv6, one router, one hardening, and one DNS workshop. And on Friday, promoting an event to foster networking, where we foster knowledge and we'd like to foster networking. To be able to improve a career, we have to have a networking, and also to companies. So setting new agreements, contracts, peering, transit, traffic. This is a pilot that we released in Petrolina, Pernambuco, and Montes Claros, Minas Gerais. And to close, what is coming next? 15 years of IPv6 Fórum. You are all invited to participate. We are going to have an award.
Segmento routing. Vamos fazer uma mesa redonda.
How about the IPv6 adoption in the segment routing? You are all invited to participate at our round table. It will be broadcasted, but please come and stay tuned. 2024 planning. We are going to still keep the intranet lives, a total of 6, capacity building week, 2 programs, layer 8, 1 chapter a month. We are going to reach chapter 50. We are going to keep on drawing e-learning distance, IPv6, Cisco. And we are also trying to set a new partnership with the new Huawei, Datacom, and to learn a little bit more about the technologies. Citizen in the network, new vertical format and tutorials. On site, we would like to visit all these regions with our BCOP regional forum. These are the regions that you can read on the slide. An AceleraNet program to those other cities. IX Forum Fortaleza will be conducted in the first semester. We had the first edition this year, and we're going to have a second one next year. Come and talk to us for a sponsorship proposal. We might publish that very, very soon. That's it. Our time is totally up. Anything else? No, we have no more time. Thank you.
Lembrando que o Eduardo, o Rodrigo, o Moreiras vão estar aqui.
They will all be available throughout the day at NIC.br booth. Milton Kashiakura our project director, and he's responsible for the CIMET project. He will give us an update about the project. Milton?
Bom dia, pessoal. Silêncio aqui. Bom dia. Então, vamos começar, que estamos um pouco atrasados aqui no nosso evento.
We are running just a little bit late.
Bem, essa daqui é a agenda de hoje, tá, pessoal? Então,
This is today's agenda.
falar aí sobre esses itens. Então, começando aqui, né? O que a gente tem feito agora, atendendo a pedido da comunidade.
Well, our community is requesting us to allow CIMET to work with providers. Since the very beginning of the project in 2006 and 2008, we started working with end users. We are still with end users, but the focus, though, is more directed to providers. CIMET now has different sides. The objective is to understand and to improve providers' internet quality throughout several measurements. So we keep on collecting users' informations via CIMET, but throughout the AS portal, we want to have that information available. As providers have requested, we developed a CIMET SP version, where we take the CIMET server within the AS network. So the measurement can be done within the client's network. But since the very beginning of the project, we have always wanted to be able to understand and assess quality as a whole, not just within the provider, but outside their network. So we add to CIMET ISP an additional measurement, which is the measure where they install the server and we measure it against IXP. But those measurements, they will just report latency, package loss to the main IXPs, to which there is some level of visibility. So this sort of information it is available throughout the portal. So users, they will know about their quality as to the main IXPs installed, a total of 36 in case that there is a presence. We are also empowering providers throughout our SARAS project. As of next year, we will make routing information available for those that will announce their routing table. What is their visibility? What is taking place within the provider's network? All of that within the AS portal. What is a ISP CIMET server? That is a server that you may install within the provider's network And we have two steps. CIMET tools will measure server measurements and offer that to their users. And the other step is a measurement probe, which will measure from server to IXPs. Probes will also help us to measure connectivity as to other probes, to understand that if participants in the IXPs, they are going throughout the IXPs pathway. So all that information will become available throughout our AS portal. Now that CIMET may have providers in their network, we had to change the way as how they choose CIMET tools that are available via iOS, Android, to allow measurements within the provider's network. So the choice has to follow this sequence. First, if an autonomous system has CIMET SP, that is going to be measured by the CIMET that is within their network. And secondly, in case they don't have a CIMET SP server, they have to choose the CIMET server, which it is within their IXP. Third, in case any of those CIMET SP is installed in the traffic, next, they will choose the IX CIMET server, and the traffic provider will disclose that to IX. And in case there is no visibility of a CIMET server of a traffic control or provider's area, they are going to choose the public server, which is available at NIC.br autonomous system. CIMET ISP. Throughout AS portal, you can get information to request and install the CIMET SP software, where you have to make available a single VM image and all the necessary hardware pre-requirements. And the CIMET ISP, as I told you, there are multiple features, so just they are here repeated, and throughout the time we will try to set different measurements and share them throughout our AS portal.
One of them is the spoofing test. The spoofing test is so much easier if you have connectivity, if the autonomous system also participates in IX. Now, if it's not an IX participant, then it's more difficult, of course. Now let me show you something. You can only make that virtual machine available. The installation is totally automatic. You don't need to do anything else. The system, it will be installed automatically. So, since we started this pilot project, we've had 72 autonomous systems with a CIMET ISP installed. It's really straightforward. It can easily scale up, and the number of autonomous systems we have today in Brazil, we have 72 autonomous systems. When a provider installs this CIMET ISP, it's clear that after making some measurements, it became clear that 77% of the tests performed, they go to the server. And then you have other tests that are still performed with the traffic or NIC's provider, because the meter lets you choose the measuring system you want. Another thing we realized in these pilot projects we conducted was that you have latency reduction. So after the measuring server goes to the provider's network, of course, you expect your latency to decrease. And with a lower latency level, the band that is obtained is larger. As a result, we get much better band measurements. So this is the QR code for you to download to install CIMET ASP. And then this is the AS portal. Of course, there's a lot of room for improvement. It's just a first version, and we're working hard to show you the data we've collected. And you can have some, at least some initial idea of how things are on this portal, the AS portal. You also have information on all measures that were made in your network. So we just leave the information available here. They're all made available, and your users, they're making their measures in their networks, their respective networks. So you have that information on AS portal in real time, or almost real time, just a few seconds in latency. That's when you get that information made available through the AS portal. One of the things we've added recently or changed recently was that users now, when they're identified on this portal, they use their IP, their port, and their time of connection. So if you want to know who the user is, we can provide that information, IP, port, and time information, and then you can relate that to the user that performed the test. So access to PAS or the portal of the autonomous system, then the CIMET measure meters that we have. We have it for a web or mobile, that's Android and iOS, and also the Linux version. So with the Linux version, we provide this measuring software through Linux, and it goes to platforms that support OpenWRT. Then we have command lines. So this version, Linux version, is a kind of a wild card that can be installed on many different platforms. We're also entering into a partnership with the Czech Republic. The idea is to have CIMET on how they sell, and we'll be conducting a pilot project in 2024 for this. One more thing we've been doing, we've been working with the public sector. So with the public sector, we provide meters to, so it goes to the public sector. These meters are made on demand to be installed both in schools and healthcare units. So in schools, we have meters in 71,000 in 140, 150,000 schools that we have in Brazil. So almost half of Brazilian schools have this meter that is gathering information. In addition to providing that information, making it available for the public sector, the educational sector, we're also providing information to be used in the first budget. This is why we ask providers to use the CEMAT tool, because by using the CEMAT tool, we can tell how close we are to the measures we obtained, what providers we obtained, how close we are to some school that will need additional capacity or even get their first internet access. So the CEMAT tool is used to map this out too. So it's easier for the government to meet the needs of all the schools that are still missing. CEMAT coverage, that's my last slide. Today, of the 5,570 municipalities, we cover almost all of them. That's 99.44% of our cities and towns are covered by CEMAT. So we measure 5,539 municipalities. They have measurement. So what we ask of you is please adopt CEMAT as a solution provider. So we're suggesting how it can improve the quality of your network. Let's work together to make sure that together we can improve the quality of the Brazilian internet. So we're working together with you, providing data to help you improve your networks. That's the idea. That's the idea behind this new version of CEMAT. In addition, we'll be also helping educate your end users. We'll also be producing educational videos to help people understand about measuring, why a particular measuring is lower than what was hired, for instance, that they're paying for. We'll be discussing this throughout 2024. That's it. Thank you. Thank you, Milton. As I mentioned, with Moreiras and Rodrigo, Milton, Paulo, and the guys will be here all day long. So if you have any questions, talk to them. Right now, I'd like to invite Fabio Sene of NIC.br at NIC.br to launch the TIC provedores or the CIT providers. Fabio, you have the floor. Hello, good morning. First of all, thank you very much for inviting me to participate in NIC's Infrastructure Week and the X Forum. For us, it's a great pleasure to be here, to be talking to you. I'll show you some results and the launch, which is unheard of our TIC providers, TIC provedores. The major survey or information they have gathered about the Brazilian internet is that it's not just about data that is collected through administrative records or other sources. In addition to this, we talk to people, we phone them and interview a important major source of companies that are really representative. So we have an idea of the market and how they feel the services that are provided to them. It's an important database. I won't be able to discuss all the details, of course, but we can give you some idea of what we did. Then this survey is for refers to 2022. Those that don't know CTIC-BR, that's a department of NIC.br specializing in statistics and data and studies about the access and use of the internet. So you're invited, kindly invited to go to CTIC's website to see other analyses. You can find information about the percentage of individuals that use the internet, companies, the government, schools, the healthcare sector. So we have a whole repository of information about internet access in Brazil. You can also access or see other capacity building or training activities that we provide. So please go to our website. Let me tell you how we collected this data, the TIC providores or the ICT providers. We want to map the entire internet access in Brazil. It's nationwide, and we have companies that have a service and communication license that was provided by Anatel. And then we provide access to everything that uses the internet in Brazil. The number of companies that have ISCM license have grown, considerably. But it doesn't necessarily mean that these are providers that are active necessarily. You might have an ISDM license for other purposes. So we decided to carry this survey out in two phases. There's a telephone phase in which we get in touch with each of the companies that were chosen to participate, to make sure they're working, that really provide access. So there's a first filtering or sifting of our database. In this edition, for the 478 companies, 978 companies we collected information about. Sometimes we needed to go to their WhatsApps or other social media pages to get as much information as possible and find out whether these companies were working. Then we had a second phase or step with full interviews on all the indicators. We'll be showing data about samples from 2008 companies that were interviewed, and they're statistically significant when it comes to companies that work in Brazil. What have we found out? Something that really caught our eye when it came to the analysis of the results. What's the profile of companies that provide this service in Brazil? If you think about regional distribution, of course, you need to consider also where you have the most people in Brazil, right? You have a high concentration of people, 35%, for instance, in the southeast region, then the northeast region, 30%, and then a smaller number of companies in the north. That was the smallest, the lowest number. There was not such a difference in terms of distribution. Our estimate of total companies providing this service following this methodology is that in 2022, 11,630 companies. When you compare this to 2020, there's a small reduction, but that means a number that has remained stable. So we are in a stable scenario. In those that are working, companies that are active, you have a different profile. And this will be seen as we study the indicators. That means a more consolidated companies. Those that are active are better structured and more consolidated, providing a more diverse range of services, provide a wider range of products. According to the IBGE from for all sorts, small, medium, and large size companies, in 2022, we have a smaller number of companies that are considered micro businesses according to the IBGE, but the number of mid-sized companies with over 50 employees increased. So we have more people working in these companies than micro companies. So we're talking about a whole set of companies or a larger number of mid-sized companies that are better structured, probably, but also a smaller percentage of companies that work in a single municipality. So the companies that we monitor, they're now probably expanding their activities to more than a single municipality. That means a more consolidated sector. You look at the types of services offered, in addition to provision, all companies offer, of course, access. They provide access, but they can also offer other services. And there's a list of the other services. You can see that the two major items we see there, both IP traffic, which has increased slightly in 2022 as transportation services that are the second, came a second in 2022. These two activities, of course, also focus on other providers. So companies are more diversified in that they now offer more services, but also we also provide services to other providers. That means that some of them are better specialized or more specialized in the service, and others prefer to focus on their end customers. Now I'll show you the distribution of IP traffic and transportation. It's still higher when you're talking about mid-sized and large companies. These companies, they're offering IP traffic and transportation services more than before. Other tools that companies have, they've also made strides. The presence of website or the companies that have their own website increased from 87 to 82% in 2022, from 2020 to 2022. So there's the presence of websites is larger than the average other companies in other sectors. So this sector is more digitalized, and contact with customers is also based on the internet. And for some cases, there's more stability of items, and then you have a whole set of websites that provide more functionalities. So there's increased offer of catalogs for products and services, and also links to social media. And when you're talking about social media, it's important that to see that as in other sectors and companies, the provision sector uses social media, and that includes both message apps like WhatsApp and Telegram, and also social media like Facebook or Instagram. So they have their own profiles, and they use these profiles to send services online. This is what you see in the provision sector. And this is also what other companies are doing, companies that are increasingly more present on these digital platforms. Now, when you think about connectivity infrastructure, we see a trend that is older about optic fiber consolidation. So 95% of the providers we interviewed provide optic fiber access in the other types of connection too.
And over here, we have a very interesting information which shows a consolidation scene where they work with their own infrastructure. And conversely, we see an increase in the percentage of companies that will combine both their own infrastructure and third-party infrastructure. But more and more companies, they are becoming more specialized, and they work not just with end consumers, but also with other providers and companies. those that will work just with third parts or both, 40% of all companies, of those companies, they have some type of action with third parts. And for the first time, we have asked about neutral networks, and 40% of those companies which have some relationship to third parts, they have mentioned access throughout a neutral network. And that takes place intensively with those companies with a lower client base. So neutral networks, they may represent an advantage to small companies as well. And we ask companies if they are in any specific IXP, especially IXBR. They have grown, and the company, many of them are not exactly in the IX, but they are somehow affected because they are acquiring services from others. But there are two important drivers, especially in the north, northeast, and meridional region. There is a stabilization, and we can clearly see the improvement that IXP had in these specific regions. And the number of clients, as we increase our database, we also increase the number of companies in the IXP or IX.br. There was a significant increase between 20 and 2022. Those that had IPv6 modality from 40 to 60% and other modalities,
E quando a gente pergunta, né,
which were stable in the period. What were the main difficulties that the company have to activate IPv6? Overall, costs and capacity, they are the most mentioned one. To overcome that barrier, especially in capacity. We have also innovative working with the protection. We know that we have LGPD. Access providers, they are affected by this new law, and they deal with the IPs and personal data information, which will require a specific strategy for that. Conversely, if we compare access providers to the average of national companies, all sectors, industry and services, we see that they are a little bit more active as to data protection. 40% of the companies, they have someone responsible for that. Have you done anything with the company, with the team about the topic? While the traditional companies, this percentage of 36% among providers, that will reach 68%, including small companies. But the list of concrete activities of each one of the providers, some are more established, such as offering a channel for customers service
mas ainda
and to develop a policy of privacy. and best practices for data protection, which is not highly mentioned, such as name someone liable for GPO. Which department is looking after that? We still see a priority in IT and smaller companies, so there is some room for improvement. And finally, security. Since 2020, we have introduced this topic in collaboration with CERT.br. Some indicators were added to safety, and which companies they state that they had suffered service attacks, and there is a stability between them, 24% in 2020 and 23% in 2022. And the client base is another correlated factor to attacks. Companies with over 6,000 clients, this type of attack may reach 34% of all companies. The impact that they report, they are quite reasonable. 34% of the companies, they said they had to stop the service completely, whereas 64% they are still operating with more obstacles to their clients, which represent a financial impact and the quality of the service, which should be taken into account. There is a demand for specialized professionals, both yellow, orange bars, but as they increase the company size, the higher the needs for their own team. Here we are able to monitor market hit to hire specific people in this field. So this is just a snapshot of what we have in the research. Our final report will be distributed here. And that is also available for download at our website. And we hope that that will be useful to the sector to understand what's going on and to monitor the access in the country. Thank you. Thank you, Fábio. Well, are there any questions? We are running late.
O Bertoldo tem ponto, Fábio. Por favor, Bertoldo.
Fábio, bom dia. Muito boa apresentação.
Wonderful presentation, Fábio.
Como é que a gente faz se a gente quiser sugerir?
If we would like to suggest any metric, which would like to see a metric that you do not cover today, which would like to see, what would be the next step?
Obrigado pela pergunta. Essa pesquisa, ela é feita em conjunto com grupo de
This is done together with a group of experts which advise us, including the providers, Anatel, RNP. We have a group of consultants
individualmente conversas
who formalize the demands, but we can talk to more specific people.
É claro que assim, a gente precisa esse grupo de consultivo existe, porque não dá para acomodar tudo.
This group of consultants exists.
Não pode ser muito longa, porque senão
but it cannot be a very long one. Some of you have probably been contacted, and you need to dedicate some time to answer it. So we are always trying to set the most relevant topics with some limited time, but we are at your availability for measurement ideas. We would like to run that again next year. So 2024, another round. Thank you, Fabio.
Nós estamos com os tempos.
Yes, running late. So you are all invited to a coffee break, and we shall be back in 25 minutes. Thank you.
Celso e o Rafael da Made for It para falar de ataques DDoS em outubro e novembro, análise e recomendações técnicas. Lembrando que a palestra agora ele vai ficar no modo silencioso também, tá? Então, coloca os seus fones. Obrigado, por favor.
Bom dia, pessoal. Estão ouvindo? Bom, vamos lá. A nossa palestra, inicialmente, ela teria um outro tema, sabe? Nós falaríamos sobre, lá em setembro decidimos, falaríamos sobre engenharia de tráfego, usando, né, NetFlow como solução. Porém, em outubro e novembro aconteceram outros eventos aí que nos fizeram mudar essa abordagem, né? Por isso a gente quer falar sobre uma análise sobre os ataques de DDoS que rolaram em outubro e novembro, e também falar algumas recomendações técnicas que nós enxergamos que sejam prudentes dos ISPs tomarem para se proteger e também proteger todo o ecossistema e a infraestrutura na internet. Vamos ver. Para onde que eu aponto? Não tá. Agora foi? Deixa eu testar. Agora foi, obrigado. Bom, pessoal, nós somos da Made for It, eu sou o Rafael Ganassim, sou co-founder da Made for It. Trabalhamos aí com consultoria para ISPs e mercado corporativo. Nós temos também soluções de software voltados ao mercado de ISP, Made for Flow para segurança e visibilidade, Made for Graph para atendimento e visualização de redes de usuário final, e o Made for OLT para gestão de OLTs multivendors. Né? Vamos lá. Pessoal, no dia 20, um pouquinho antes do dia 20 de outubro, na mídia saíram várias notícias, né, sobre ataques que estariam acontecendo, né, em decorrer da guerra de Israel com o Hamas. A gente pode ver aqui alguns dados, até Inside, falando de que o ataque volumétrico aumentou em 400% no ano de 2023, né? O pessoal da Internet Sul lançou também uma notícia dos cyberataques, aqui, afetando milhares de provedores no Brasil. E aí teve a ameaça, né, desse grupo Irox Team, ameaçando atacar o Brasil a partir do dia 20 de outubro, né? Quando nós vimos essa notícia, a gente ligou o alerta, né? E, infelizmente, de fato, esse assunto se concretizou, né? O ataque aconteceu, os ataques aconteceram, e já vou mostrar para vocês. Tem aqui um Twitter também, do pessoal, né? Prometendo o ataque contra o Brasil e contra outros países que não se posicionaram como eles gostariam, né? Algumas outras notícias, então foi amplamente noticiado na mídia sobre esses ataques. Aqui eu tenho um gráfico sobre o histórico de ataques que nós pegamos nos sensores da Made for It, né? Eu vou virar aqui, mostrar para vocês que em setembro a gente detectava aí uma média de 4.000 ataques por dia. O que é um ataque na nossa visão aqui, gente? A gente chama de anomalia dentro do nosso software, ou seja, é a composição de um ou mais ataques com a mesma assinatura, com destino ou a mesma subnet ou o mesmo IP, né? Então era uma média de 4.000 por dia, bem tranquilo, porque são sensores espalhados no Brasil e na América Latina. Porém, olha o que aconteceu a partir de 20 de outubro. A curva de ataques, ela ficou muito maior.
The attack curve became much greater. We had an increase of 270% in the number of attacks. The analysis, they were done from October to November. We had 17,000 attacks and almost 370 attacks just in November. For a month period, so we had a huge volume of attacks over our network. Here we can see the type of attacks in high-level protocols, and DP Food was the guy who was mostly attacked. followed by CMP. About the attacks, let's explore and try to understand them. I'm going to follow a reasoning line where you'll be able to get the same approach that I did to interpret data. So data is anonymous. We have used some of our clients and we have talked to all of them. We told them that we would do that analysis anonymously, and we got just some attack signatures to bring to you. We don't aim to be a scientific exploration, that is more a qualitative one.
Vamos lá, gente. O ataque 1, para a gente explorar ele aqui. Ó.
Attack 1, let's explore it. On the upper chart, we see the flows. They were stable down there. They working normally, and suddenly several peaks of UDPs. Here you can see the flow traffic per second. Several peaks during the period. And below, we had the ICMP flow, exploring ECMP and DP. TCP flows, they did not change significantly, so I even removed that for the sake of time. And this specific client, we had their flow, 100,000 flow of peak against an average of 5,000 flow. And in ICMP, this is one specific network attack, but the signature was repeated at several clients, hundreds of those that were with very similar and close signatures. What protocols did we have the attack? First, if that is IPv4 or IPv6. Although there was too much IPv6 alterations, actually less than 40 flow, and in IPv4 that has been released. So that was started low and then went really high. So the attack was over IPv4. Second characteristic, what protocol was used during the attacks? 78% of the whole additional traffic was UBP, followed by 17% of TCP. So this was a volumetric attack. Let's keep doing it. Let's building it up. Now let's understand the most used UDP ports. I got 3 test sensors. First, DNS, and second, zero door. I will explain you later why. And then communications of high door. On these 3 comparisons, the DNS was the guy that was mostly offended, followed by door 0. On a much lower scale, we have the DP. 290-fold the traffic of PMS within our network. Door 0, I did not even check that out. Before that, there was no traffic of door 0, and during the attack, that has been increased to 100,000 flows. But anyhow, we want to get the main signature, which is the DP volumetric shortcut, being the main DNS traffic and door 0. Let's keep exploring such an anomaly. Guided to whom? Well, that question has been asked to understood if that was an attack done to one ISN IP or to all of them. In orange, we have a common regular traffic. Subnet door 20/24. There are subnets.
E de repente, durante o ataque, olha como que estabilizou, né, o uso sobre
that were
todo.
not used during the attack.
Vamos olhar a distribuição agora como que fica.
How about the distribution?
Ó, antes do ataque, o gráfico
Before the attack, the chart on the left had two subnets,
possivelmente um CGNAT ou o serviço dele estão nessa subrede.
CGNet or something else.
Muito tráfego em duas subnets.
Too much traffic in two subnets and all others with small traffic. During the attack, what happened? Each slice of that pizza is an individual subnet. There were some with no hosts with the same volume. What should we take into account? A DP volumetric attack, DNS offender, and or 0 to all ASN networks. Let's keep going. How long did the attacks take? Well, here I see so much variability. No attack lasted exactly the same time, but they had oscillated between 40 seconds and 120 seconds. So attacks between 40 seconds and a minute. So we have a volumetric UDP, DNS traffic, door 0, lasting up to 2 minutes. Which countries? If the attack is coming from Brazil, that is a piece of cake. We can just submit that to a cyber crime police station and be active. So let's see this client's traffic before attacks. On the left, we see countries, and 90% of the traffic comes from Brazil, US, on a normal day with no attack. By continent, 96% of the traffic, they come from Latin America, North America, just a little going outside, abroad. And we have to take a look at the geolocation. If they say that that IP belongs to the US, fair enough. And how about during the attack? Once again, we have a pizza. It's so crazy. It's all inverted. Full countries, and the country list was huge. There would always be someone sending something to their clients. Brazil and the US before, they would represent 90% of the traffic, and now they represent less than 20% of their attack. Where did we have most of the traffic? In the APNIC region, in Asia Pacific region, countries that had a higher level of registers. APNIC countries, Asia Pacific. Which links? Throughout which links were the attacks done? If we have a high ports UDP attack,
então, alguma coisa vem pelo X, coisa ali de 15%. Agora, olha quando vem porta
traffic or IX, door 0 or DNS attack. Here we are talking about the worst case scenario. Our goal here is to foster in our IX community that IX is a safe environment for operations. But unfortunately, today that has been used just as well to attack ourselves. So that has been an attacker. You know, I cannot let Bangladesh attack in my IPs. It would be ideal if IXBR would no longer be attacked, or at least if they could be traced or tracked, allowing not allowing IP spoofing. We have to deal with those cases of attacks leading with IX. So 30% of all attacks, they are done via IX.
Provedores, operadoras que forneçam essa possibilidade aos seus clientes.
Both operators, what carriers and servers that they use, that they do this. And there, of course, there are cases when you have an attack on all the IP, so you cannot use a black hole. But it's just a couple of them. Then you can send that. Now it's rather, of course, make one or two clients go down than everyone being affected. You should have a BGP flow spec session. That's one of the best technologies to solve this type of attack. You can send ACL rules with the fiber and ports. So if you get an attack in port 53 and send to your carrier to block that traffic, it won't even reach you. So you end up saving money with this technology. Then you have, of course, BGP communities. Have them in hand. Also hire mitigation links. It's an expensive service, so if you don't have computing capacity and also enough links for you to mitigate it locally, you need someone to do this for you. So they should clean it up and send it back to you cleaned. Then you need an attack detection tool, NetFlow. In order to do everything that preceded this, you need to monitor your traffic. You need to know what kind of traffic you have, the traffic profile you have in pages 53 or a port 0. We found many ports on the internet. There's some links you can check later, so you can monitor them and have your traffic profile to detect in your detection tools to have the best alignment possible. It should be aligned to your network. Avoid unnecessary use of public IPv4. People just upload IPv4 for everything they do. It's not necessary to do this. You can save public IPv4 and you avoid having an additional open IP to be attacked. With the use of soft routers, we know they're good, but during an attack, you have problems because all the traffic goes through your CPU. So when an attack comes, no matter how well set up your equipment is, you will get the blow. IPv6 implement. This is essential. Most of the attacks, 95% of attacks today are on IPv4. So if your network is well aligned in IPv6, in some cases, you can even have limits in IPv4. So your IPv4 traffic will keep working without your clients receiving the impact. Then recursive anycast DNS that will make you just will be, hearing private IPs. And then remove static loops. Those that work in networks, you always get this problem once or twice a week at least, and that might kill your network. Now we have some images. I don't have much time, so I'll just skip them. But this is a topology example by X, a hired mitigation cloud, and also flow spec in black hole sessions with your carrier. Then static loops. So I have the link of Marcelo Gondim's paper. It's on BPF. This is a great paper. You can check static loops. They have a great script there in this paper to help you find this kind of problem. The static loop, for those that don't know it, it's like, suppose you have an attack that will reach your network and your IP, suppose it's 192.0.2.0/24. So it goes from BNG. The BNG doesn't have that installed route. It will be returned to the edge. So it will be between the edge and the BNG until the TTL blows. So if it's 1 giga attack, it will be there until it will no longer work. It's really important to solve this kind of problem. You can also validate static loops in the Radar by Crater. Every provider should have their ASNs this way on the Radar portal. One example of recursive DNSs. You can have many recursive DNSs, 2, 4, using the same IP. You can create one DNS for each /24 to make your requests and answer to your clients in the same public IPv4. So we have a change there. IPv6. This is Google statistics. In Brazil, it's about 45%. That's the amount that Brazilians use in IPv6. These are some recommendations for us as providers to prevent us from being the attackers of our partners. We need a secure network. You need regular scans to find failures, defects. There's some tools like OpenVAS. It's very good to scan your network. Then you need to close your equipment management doors, except for your management network and your BNG. Communication between your customers in your management port should be blocked. If you have an infected customer and you don't have protection, this particular customer can infect all the others that have a particular failure in a particular vendor. Now, make sure your equipment does not have problems in ports like SNMP, NTP, DNS, port map. You need NetFlow monitoring not only on the edge but also on your BRAS. So if you monitor your BRAS, you'll find clients that are generating this type of attack in your network and then take action to address this. Then you have your update. Make sure your registrations or records are updated, like ERR. If we happen to be an attacker, we should work toward solving the problem. Then join the Manners project. All providers should do this. This will help the entire community. Then implement BCP38, that anti-spoofing. If you get an email, it means you have a problem. Answer this as soon as possible. Identify botnets on your network and block ports that are commonly used for attacks. You have a BPF link. So you have many ports that are widely used for attacks, for the purpose of attacking. This is an example of the CERT-BF. That's the 2021 capacity building week, training week. So we have now lines that are checking some DNSs that are not public DNSs. In this case, I gave you one example. That was November 31st. So two IPs that were checking DNSs that were not the ones that I defined earlier. These two cases were found, so you can identify easily who is looking for DNSs that are unknown, and also your own recursive DNSs. Now, during an attack, should monitor your network. You need to be a partner with a good partner with your carrier so that your carrier helps you. Now, other things that can be done, I'll just skip some of them, but if needed, if the need arises, should detour your traffic for mitigation up, so you remove it from other carriers that don't provide protection and send it to one carrier that will clean that traffic up. You can also have a limit for insecure DNS servers that are unknown. There are some alternatives here that might help you in these attacks. And use FlowSpec as much as frequently as possible with your carriers. That will be really helpful. Now, another thing that we usually do is when we are under attack, and it comes from IX, you set your prefixes to ISNs that we consider secure only. So if I have a list of ISNs that you consider that are secure when you're under attack, just send your prefixes to these secure ISNs. Some communities you can use to do this. Now, mitigation. This is an example of a topology using a net flow collector. In other words, you're making an analysis and sending it for mitigation via FlowSpec or black hole. This is a screenshot of one example of a FlowSpec, BGP FlowSpec I wrote on Huawei. So you have FlowSpec and you give a denial. You can also do red limit with FlowSpec. Monitoring. You need to know your network in detail. You need to monitor the ports that are used for attacks. So when you have a problem, you can easily mitigate it. We have some examples, DNS ports and zero ports, but this you should do to all ports that are commonly used during attacks. An example of a free tool called NFSend. Some cannot afford a NetFlow tool, so you can use NFSend. It's really easy to install. So we'll start monitoring all your network and find out about your traffic profiles. These are recommended readings. Article 11 of BPF, and also anti-spoofing. Okay, I'm running out of time. Thank you. Thank you. Thank you, Rafael, Gelson. Thank you for your presentation. We don't have time for questions now, but thank you. Let's now continue and invite Daniel D'Amito of Stage Networks. Daniel will talk to us about the 95th percentile, how to save money in the right way in IX.
Tá bom. Deixa aí. Tá bom. Então, pô. Bom dia, pessoal.
Good morning, everyone. First, thank you so much for coming. I'm so happy to be here, to have a full house. Thank you, NIC.br, for this conference. It gets better every year. Let's go straight to the point. I have a great challenge, which will be hard to achieve, and this is to talk about a highly complex topic that's at 95th percentile in a very short amount of time. I'll try to be fast if you have any questions, and if you have time for questions, I can answer them. Otherwise, we can talk later. Our booth is there. So before we start, this is Sage Networks, where I work. We have three major services: DDoS, attack mitigation, technical consultancy for internet providers, and also strategic consultancy. So strategic and technical consultancy made, we get that know-how about the 95th percentile we'll be discussing today. So the topic of my presentation is the 95th profile, how to save money the right way in IX. Some people go to IX to save money, but they don't do this in the right way. So I'll explain this to you. How do we purchase traffic in Brazil? If you take one hypothetical example, suppose you have a maximum consumption rate of 2.8 gigabytes per second. So they buy 3 gigabytes per second. We don't usually make such an accurate calculation in practice, right? So it's an estimate. So based on this premise, companies make some of the following bad choices I'll be showing you. Number one, bad choice. Number one, buying a 3 gigabyte per second link. Of course, you're saving money. That's the pro. But the con is you don't have redundancy or high availability. So that's one bad way of buying it. The second bad choice is buying 2, 3 gigabyte per second links. And again, the pro, of course, is high availability and redundancy, but the con is a very high cost. You need to buy 2, 3 giga links, and you have a lot of bandwidth that will be underused. So that's not the best. It won't be used. Another option, and this is the one I want to discuss more deeply, they buy 1 gigabyte and transportation for 2 giga for IX. Okay, what's the pro? You have some pros. It's a much lower cost than the two previous options, and then you have good connectivity as you're on the IX, on the PT. And by the way, IXBR is the largest in the world. Now the con, if there's any IP link unavailability, a lot of the content will be out because IX is not internet. It's a huge part of the internet, but it's not the whole internet. So if the IX goes down, the traffic will not be enough to meet the provider's needs. These are the three major ways or choices that companies make. So is it good? Okay. Is it all right now? So these are the three major ways you can buy traffic, IP traffic, but none of these options meet the need of both availability and cost. There'll always be something out. It's a high availability or a high cost. And in Brazil, we have two very common solutions to this problem. One is the informal burst. So for your information, it won't find it in books or in literature. It's just my own way of naming it. And number two, it's the 95th percentile. What's the informal burst?
The company will buy 2 giga traffic to IX, and there is an IP traffic with some provider. If they go down, they call their IX provider asking for help. And this provider may or may not help. Why can they help? They can help because they are nice, but at the same time, they may not help because they may not have ability for that, or due to a commercial reason. Is it fair if I release more band there is no reason why they will do an upgrade. So there is a high likelihood that this provider will not help. We cannot be hypocrite and say that the informal burst does not work. The Brazilian internet is the largest in the world, and they work thanks to informal burst. But they have some issues. They depend on the availability of supplier capacity and good faith and commercial cost. These are the requirements to release informal burst. And there is no contractual guarantees. If you will require that, there is no way to fight for that, because that is not in the contract. So it works, but with some issues. And there is a miracle solution. 95 percentile is not new. The whole world uses percentile. And what's that, 95 percentile? That is a model that meets the first requirement. It also solves cost issues, and it's widely used.
Quem daqui não conhecia, nunca ouviu falar de 95 percentil?
Who has never heard about this percentile?
Levantou a mão nenhuma das duas vezes, é estranho, hein? Mas que bom, bastante gente já conhecia, tinha bastante gente que não conhecia. Eu vou explicar um pouquinho mais a miúde como que é o 95 percentil, tá? Quando você vai contratar o link,
what the 95 percentile is. If you are going to negotiate two values and not just one.
Fornecedor é o commit, o compromisso, tá? Tem um nome mais antigo que é
There is an older name, SIR Commitment Information Rate, which is a much older name, and this is the value throughout which you are going to pay every month. And this is a minimum value. Every month you are going to pay for that. Consuming it or not, you have to pay for that. And the other value, the other amount is the burst, the maximum information rate for use. You are going to buy a link with another burst value. You may overpass that free of charge, up to 5% of the total hours of the month, which is approximately 36 hours. If you exceed 36 hours, you are not going to pay anything extra. 37, you will. If you surpass those hours, there are two conditions. You have to overcome that 37 hours in the month, consuming 700 mega. And once you exceed it, you are going to charge additional value. If you use 37 or 90 hours, I just use 37, I'm going to pay less. No. If you exceeded any hours, you are going to pay more. You pay extra, whatever it goes beyond those 95 percentile, I mean. How is the traffic measured? Several measurements are done for the consumed band. They are done every 5 minutes. There is no rule or a standard. Usually they do that every 5 minutes. 8,640 measurements monthly. If there is any other equivalent system, they are going to measure that and then to write down. By the end of the month, 50% of them will be released. 50% of them, 432, they are disposable. Did you get the math? If not, I can give you another example.
Isso daqui é uma tabela, exemplo de medições.
This is an example that has been organized. The system will measure it. And then I have organized 1 to 400 or 400 to 8,000. They were omitted because I couldn't place them on the screen.
As medições que foram descartadas aqui nesse exemplo foram do 0, do 1, na verdade.
So we had disposed 0 to 432. What do we have left? 433. So the measured amount was 1 giga 269. Did you understand? Can I tell how much the company is gonna pay, or if I'm gonna pay anything extra?
Notem que os valores em branco não são relevantes, tá? Isso significa que, independente do tempo, se ele
regardless of time, if they would spend all month consuming 1 giga, they would not pay anything extra. But if you exceed the percentile, 10 giga, 1.5, you may keep on using until the rest of the month.
Esse próximo ponto é o que eu acabei de falar para vocês. Vou dar exemplo gráfico também. Isso daqui eu peguei desse site. Ele tem valores bem pequenininhos aqui.
They have small values.
Esse é gráfico normal, tá, de consumo. Vocês vejam que ele oscila bastante, né? Obviamente.
They oscillate a lot.
Se a gente ordena esse gráfico,
if they coordinate this graphic from the higher, from the bigger to the smaller, 100% of the monthly hours, whatever is missing is exactly what is going to be charged, that is going to be the over. There are people that understand better with the graphics, other with templates. Fine, fair enough. How much are they going to pay for a provider 95 percentile? Well, you always pay for the minimum value. If you have something more, you have to pay always whatever you own plus the excess. They usually cost more than the regular price. There are many companies that they sell that for the normal time, for the normal value, but that's not a rule. Usually they cost a little bit more than the regular one. But why do they cost more? For the traffic IXP to have more profit? Você acha que eu ponho no carro que eu vou levar para Maresias? So IXP, we don't find just anywhere. Those are not free of charge. If they hand in percentile, they have a cost to be able to use. So if you got that, you have to pay a little bit more. This is a win-win relationship. Some value examples. A regular mega costs 4 BRLs, and the other one is 50% more expensive, 6 BRLs, and that amount may vary. It's 20, 50% more expensive, and there are others that they charge exactly the same amount. Another example, ISP hires 1 giga for 4 BRLs each mega. It has exceeded the band for over 36 hours in that month, and the measured time was 2.5 gigas. How much will ISP pay for? Those 4,000, which is their commitment, as well as an exceeding value. 2,500 megas minus 1,000. As the price of this exceeding mega is more expensive, he's going to pay another 9,000.
A despesa dele foi de 13 mil reais. Beleza?
13,000 BRLs. That was his total expending. Was it worthwhile paying those 9,000 exceeding this month? If they had pre-hired 1.5 gigas, they would probably have paid 50% less. Was it worthwhile paying for this exceeding amount? Well, let's check that out. If they had contracted every month 1.5 extra giga, not burst, but just this extra 1.5 gigas, he would pay every month extra 6,000 BRLs, a total of 72,000 BRLs yearly. So we have a surprise spending of 9,000 against a recurrent 72,000 yearly. So it was worthwhile paying this exceeding amount of 90,000 because that represented a great saving. Disconsidering eventual discounts, if you would renegotiate it, you could have a discount in the mega amount. So I'll give you more straightforward examples as my time is quite limited here. This is a table where you see first column, months of an exceeding company of 500 mega, second column, if they contract with 95 percentile, if they pay for an exceeding amount. The third column, if they contract that amount fixed every month.
1,5 GB, né, naquele exemplo. E ali na última coluna é o saldo.
And in the last column, we have whatever is left if they use the percentile, if they are positive or negative. If it's 1 month, that is very positive. If they exceed 2 months, we are going to have an economy of 154. So they're going to be favorable, exceeding the band and paying a higher price for the mega. And then that is going to be a waste. So this is an example as how percentile can indeed help to reduce cost. So they have to have a percentile contracted. Otherwise, you are going to leave the illusion that I access internet and it's not. For 8 months, no profit nor damage, and then they have a financial damage with the use of percentile. Percentile almost always will be an advantage, even though you have to monitor the band consumption. So you should monitor and be aware. If you have a link which is every month absent for over 36 hours, you have a serious problem. You have to revise your supplier. You may monitor by your own, on your own, I mean, or you may call us to help us to implement percentiles monitoring. And if you don't use them, I'm sure that you are opening this availability, capacity, savings, or guarantee. Even though you have an informal burst, they are going to meet other requirements, but with no guarantee. So the percentile is the only feasible way to fulfill your requirements. We are going to develop soon a tool that will help you to calculate You have to do that by hand today, but we are going to calculate 95 percentile, and we are going to have that available in the internet to simulate different scenarios. If you could follow us in the social media, do so, please. This is our QR code. And last but not least, to benefit from the 95 percentile benefit, the company should have some kind of cash flow. Otherwise, if they exceed, they will have to rely on some financing line, some kind of mortgage, because that huge saving is just possible throughout 95 percentile, and that you need cash flow for that. Thank you to Sage Networks, to Sparkle, and Hexa Networks, and all these guys who had helped me to put together this content. Thank you. Are there any questions?
Para vocês falarem.
Obrigado, Daniel. Uma salva de palmas. Por favor, se identifique. Pode seguir.
Só um instantinho, peraí.
Só um minutinho que o Daniel está colocando o fone aqui.
Parabéns pela apresentação, Daniel. A minha primeira...
Congratulations. My first question is, do you believe that the natural way would be that most traffic operations, they will sell the 95 percentile flexibility? For sure. And we have a scenario where most providers, they sell informal burst, 95 percentile. I hope that everyone complies with that and uses it. I'm sure that you'll be able to help us to disseminate its use, hopefully. Second question. In your experience, do you believe that it's feasible to have that percentile with a mitigation cloud, which would offer a service like that? The mitigation is a link protected against DDoS. Hire a traffic supplier which will supply that traffic, anti-DDoS, but they are not able to cancel one to meet their episode of attacks. They have to hire. What is the solution? Contract a mitigation with a lower commitment and with a burst that will meet its capacity. This is a way to allow providers to mitigate. 95% percentile will be feasible. 10 gigas. Do I need to mitigate all of that? No, you may hire that with a lower commitment. Thank you. Thank you, André. Okay, thanks, Daniel.
Obrigado. Agora, tivemos que fazer pequeno ajuste na agenda.
We will need to change our agenda slightly. So I'd like to invite Bertoldo, of course. POP RS. Asymmetry of IXB's traffic, characterization causes an impact. So Leandro Bertoldo, please, we're waiting for you on stage.
Eu só estava esperando a projeção.
Tem microfone.
Muito bem. Olá, bom dia, pessoal. Até aproveitando.
Good morning, everyone. As I noticed that we had at least a couple of DBOS presentations. Well, we have a problem here. In this is receiving IDOS on internet exchanges. So the beginning of this research was by finding out that some of the attacks that were related to internet exchanges, they, in theory at least, there was no one there in that particular internet exchange that was announcing that network. There was no prefix fraud. In the other case, one of the techniques to solve mitigation problems, of course, to change routing. And we noticed that some of the ASs that were in IX were impossible to change. So we started investigating and we found there was an asymmetry. There was asymmetry there. So what are we referring to when we talk about asymmetry on the net? They say you go through one link and you go back on another one. Well, this is about AS asymmetry. When we're on IXP, you look at the route table, and this is what the route table we see. This is what we expect. So I send traffic to this other one, and I expect to get that again, but that doesn't take place all the time. In fact, it just takes place in 85% of cases, depending on the IX, and there's variation. 85 is just an average. There's considerable variation between IXs. One more thing that takes place is this. So you, so well-behaved, send more traffic to a partner that's connected on IX, and I'm talking about ISs that are directly connected, right? Not any other ISs. And even though they're directly connected, they prefer to send their traffic to another place. There's a third case. That's a kind of weird case that was not documented in literature, and that's the following. I have no one connected in IX, so I sent my traffic through my provider, my internet provider, and surprise, surprise, the error was below, right? So this is an animation. So I'm getting traffic through IX to a block that is not on IX and was not expected to be there. So these two cases, we consider them asymmetric AS cases. So we have an average of 15% of asymmetric cases here. And what is the effect of this this development? When you look at IXP, this is the kind of curve that you get. The IS is only going there. So you get traffic, but you never return anything to IX. And this might be a little confusing, right? The inverted chart. That's one that we investigated anyway. So basically, what are the problems that this asymmetry make? You have old problems, like I'm estimating latency for a particular destination, and I find that it is much higher where I should have direct connection. So latency is much higher there. So I misestimate the latency, so traffic will be sent someplace else, farther away, and it could be closer. I saw a presentation in GTR, and people were encouraging everyone to use a looking glass in their IS. Why? Because that's an easy way of detecting this asymmetry. So the easiest way, from an operational perspective, is getting to the router or a looking glass as inside a particular AS and see if the route is still there. Right, and the last one, that's an optimization problem. So CDNs uses DNS to optimize prefixes. So you go to the DNS in Porto Alegre, and the city of Porto Alegre, and the CDN will say, look, I got this, latency is good, so I will provide the geolocation of this guy, although it says it's someplace else, and I'll deliver this prefix. So this is used with geolocation by CDNs. And then there's new problems that we also found. And these are like, these include a small CDN, I'm starting my operation, and the cheapest way is, of course, connecting to IX. But then as the CDN starts operating using this model, the CDN realizes its latency is much worse than many other CDNs that are much better structured, larger CDNs. So they get better results with other providers. So the many small CDNs, they leave or no longer use the open bidding system, and they hide behind a large access provider because they remove this complexity of treating routes within the CDN to find the best route, the lowest latency route. Another problem we found, that's a real case, and that's a advertising company that sells advertising for pages, right? Depending on wherever you are, they show a different ad. The account or the bill was very high. One of these hyper giant providers, so it hosted everything. We use a bucket or a WS platforms, and then if you're in a region and the platform serves you by a server or a database that is in another region, they charge 4 times as much. So in this particular, for this particular company, it was found that the rate was priced based on the location of the IPs rather than whether they were getting traffic or not. So there's asymmetry. The moral of the story is this: they reduced 100,000 euros a month just by showing how this, what was going on. So it's a new problem that may be taking place. Then a good part of the DDoS, if you find strange DDoS cases on the network, that's another thing we started to investigate. So what do we know? We know that small CDNs are leaving IXPs and open peering and looking for a traffic provider. Big CDNs, they prefer local bidding, private local bidding, rather than being in the open. Some of them no longer talk about open bidding anymore. And this is a problem for smaller networks. And this is the cost of maintaining many BGP sessions with many different CDNs. If there's a small CDN, it's not heavy enough or substantial enough to have a private with tier 1. Another problem is remote peering, but we're not discussing this. We also found that in IXPs, you will find some IXPs where you can take 38% of the entire global internet from that IXP. You might remember that it was 40, I think the 40 presentation, they showed CDOSs coming from Vatican Electric and others, and we found that kind of thing. Also in part of the presentation, we want to find out what these large ASs are doing. So these are some specific IX numbers. If I go to the Brazilian IX, I'll cover about 75% of the entire net area, and about 83% of all prefixes that are located in Brazil. So it's highly representative. The AS that are connected, ISs, are really representative of local traffic, and that's an advantage for IXs. So when you're DDoS and you see the traffic, you go to local traffic. So it's highly likely that we can do this through IXs. Then the question started, what do we want to know? How many of those ASs that are directly connected to me on IXP, are they really using the traffic path, or they're preferring the access provider? And then for each of the ASs, how much asymmetric are they? I mean, how asymmetric are they? Are they the same or different? There was a variation of up to 20% from the worst to the best asymmetry case. So this was a metric proposal comparing the use of asymmetry. And then, as we have this problem, what can be done to decrease or solve or eliminate this asymmetry? So we chose 5 XPs, 4 of which You see their position in the ranking, so 4 of them are among the top 10, and one is a smaller one, a more regional in the state from the state of Rio Grande do Sul. So the problem was how to identify and how to measure this. So we use the platforms. The first one was on Ripe Atlas. It's even a crowdsourcing platform where you have like a little box inside the provider, and then it lets someone to measure. Let someone measure like 3 routes to measure what we can see. Now, when you go to, when you try to measure IXP data flows, we notice that even where it is good coverage, like IMX6, we can get up to 59% tops. So I cannot cover everyone who is inside IX. If you go to other places, like IXBR, using this platform, I can only cover 4% of ASs in any IX in Brazil. Like, for example, São Paulo, where we have all of them. So this was, again, very hard problem to solve. So we needed to find a technique of solving this and of measuring this. Another approach, we have flows. So let's try to use data flows. The first problem was, how can we get access to these flows? So we started to investigate. We have problems, legal problems. It's really hard to get access to these data. So we used just the flows of one of these IXs for the validation proposal to validate our method. In spite of that, if I look at the flows, I cannot identify asymmetry there. I can identify, it's a statistical analysis. So if I send it to someone, it's outside IX, I no longer get that information. I can only be sure, I can only know who is the symmetric guys, if you will. But the asymmetric, I cannot determine who is asymmetric. I can't. Now, another case is that routing is dynamic. So I might have members that are changing their ads or that are disconnecting or reconnecting IX. So we measured based on stability criteria, and we found that in IXs in general, you have stability that is above 95%. So it hardly ever goes down. And how did we establish this method? We used an RCast network. We use a lab called Tangle that is connected to many places where you have websites, and we announced our own prefix there, the /23 for each of these sites. And the method is you're connected to the provider, and by being connected inside the provider, we make the announcement of our blocks, and we also announce this on a website that is based on an access provider. What are the things that are hard to measure is, well, asymmetry depends on my access provider. Right, that's true. So what are we doing? We're just considering the worst case scenario. Suppose you have the worst access provider in the world. Your route is totally not preferred, like you're 20 AS away. Even with a direct connection in IX, your neighbor prefers to deliver it by far through the worst route or path. So this is the worst case scenario, right? Well, in other words, the best symmetry possible. So in any other case, with any other provider, the figure will be worse than 15% asymmetry. To give you an idea, when you think about remote peering, people say that's 50%, 48, 60. That's the magnitude. So if you measure the worst in 15, they probably get to similar numbers. Of course, considering, they'll get to 50% considering their conditions of most providers. And we made 2 measures. In one of them, we generate somewhere externally on the internet to measure one side of the asymmetry, and the other one, you generate the prefix inside the IXP and measure it internally. And that will change, of course, depending on traffic is generated. It might come back or not, even if it's the same prefix, like a global network that is connected to many IXPs around the world. Our results. We found very interesting cases. One was already expected, and this is the path where I send it to IXP, and I get it through my access provider. So we have about 12%. That's the amount that we found in 12, 20, 15% in different numbers. This is just one specific example, right? I didn't take note of which one it was. And these are neighbors that we call deaf neighbors. I'm announcing my prefix. It's the best way, the best route. In spite of that, they're not giving me traffic back. They're not returning traffic to me. There was another unprecedented case that was unmapped, and that's what we call dumb neighbors. So they don't announce. They're connected to IX, but they don't announce or don't announce that prefix. But then, surprise, surprise, when I send somebody to that network that's not on IXP, I get legitimate packages of that particular network, and that's completely unexpected. These are the ones that we call the dumb or non-speaking. Now, this is a chart we saw before, and there's here one case that we investigated a little more deeply. So I'm seeing lots of pages on IX, right? This was not expected. Okay, we compared it to the global table, and we found that this in IX was larger, and we'll be discussing this later. And then the other task we did was, okay, I'm using /23. Let's try to use the traffic engineering technique. Let's make it even worse, up to the prepend limit. That's on the other side of the world. Let's try to make it even worse. Let's have /24 in IX. These are techniques that providers usually use. Or let's have a block, more specifically on IX, and see whether it will be returned. It comes back. So even for some prefixes where you have just /24 in a single IXP, even in spite of that, providers preferred delivering it to another place in the world. So they were totally ignoring all ads or announcements that were on IX. We consolidated these numbers. You see arrows pointing upward and downward, and we found that of the two types, we have only ingress. In other words, they just sent me the prefix, or only egress. There were other techniques where people suggested using MPLS to control egress networks, and this is why they're successful using this technique. So they use new network technologies. Now, who are these guys? We saw that these asymmetric networks, they're not your standard. You have just few ASs that are like this. And who are these ASs? These were just large networks. We expected them to be just small. And we found about 10, got in touch with 10 networks, and we were asking, why are you doing this? And they said, look, am I doing this? I was not expecting to be doing this. Let me talk to my consultant, my IBGP team, to analyze this. And then he said, oh yeah, well, yes, this was a mistake. Like half of our networks were not being announced to IX, or the ones that diagnosed mistakes got to 50%. So half you could provide that service through IX and get in touch with the team. So is this what you really want? No, no, no. We didn't even know we were doing this. This was wrong. And the other one, that's about 13 companies said, look, this is the company policy. We really do this. And the reason they didn't explain it in this reveal it, we believe it's commercial reasons. For commercial reasons, that's what we suppose. So some takeaways. Most of ASs, few ASs are responsible for this asymmetry situation. And the second one is that a good part of them, almost half of them, they're a result of a configuration mistake. And what is the effect of this asymmetry? You measure some IXPs. Let's try to impose /24 rather than using /23.
What have we seen? Whenever we compare, and we may see that throughout the analysis, there was not much difference in terms of RTT prefix. As you can see, we had an average of RTT of around 20, 30 milliseconds, and that average became two, one closer to 20 to 30 milliseconds, and another one that went up to 200 milliseconds. This is one of the things that CDNs, they complain about IXPs, which the routes of IXPs, there are several bad quality routes, are high RTTs. There are other metrics, but after all, this is the one that really matters the most. Fine, and which ASs have some sort of asymmetry, which could be 100%, or it may take place in levels. So you may select what extent of asymmetry is acceptable. One AS and the number of prefixes announced. If they announce, let's say, 3, 4 networks, and one of them is asymmetric, they may say, no, that is quite acceptable. So they manipulate variables to know how much they will accept. After manipulating the equation, they'll get a list of all ASs that are within the standards. They're going to say, fine, I don't want to talk to you because they are asymmetrics. This is the goal. The main asymmetry problem are access providers. Well, they are small, they have issues with BGP. ISPs in averages, they, behave well. But mobile network operators, fine. They have several asymmetric networks, one type or another. Fair? ISP, ISP mobile. This is a classification based on IP collocation. Moreover, opposite traffic, those that deliver traffic within the IX, but they have no prefix. And they were CDNs mainly. They would just send me entry traffic. There are some CDNs which operate, such as Rio Grande do Sul, Akamai. They are there. But they announce what? 1, 2, or 3 prefixes. And they would use that way, that route, and due to geolocation or others, RTT, they would generate some sort of asymmetry. There was a test we did where we say, fine, how can we reduce asymmetries? If I have some magic, am I able to solve an issue? So we tested /23, 24, and to our surprise, although there were ASs with no convergence, the general asymmetry has improved. The traffic was more symmetric. Fair enough. I just send traffic and I get that somewhere else. So I'm getting lots of bad ways and routes via XP. Comparison, fine. Let's compare with global routes table, where there were several years of sample. And here the number of AS and growth throughout time. And the same we did with IXPs. The only database available was the one that we built up throughout time. And there is much more prepend than in the other table, proportionally speaking. So this is just one example, nothing special about that. And in case of links, 30% of all of them suffering some sort of prepend. Variation, 26 and 31%. They were about in the same line. What made us think if what I see here is not exactly what they prefer to do for their IXP than using the XP route. So they prefer prepend. And who is doing prepend? Okay, the chart shows 3 lines. One is doing prepend to one provider, but to our surprise, we have this green line, which means that I am the provider, I am connected, I announce my prefix, and my clients, I place 3, 5, 8 prepending. What will motivate them to do it? Well, no answer for that. But that's funny, we do not expect it. I want to use the XP traffic to use the best traffic for it. And that's not exactly what we see here. This is the links case. Fair enough. DDoS presentations, they showed us several DDoS of Hurricane Electron for reflection somewhere in the globe. So we found those big guys here that were in the open peering session, and one of them was the Hurricane Electric. And here we see the M6 and 6 in number of prependings. This is the lower line, Hurricane Electric, their clients doing prepending. This is what we see of all prependings. And what is the influence of a Hurricane Electric? Which are the routes which we consider of being of low quality. What is the conclusion? 24% of all ASs connected inside, they avoid traffic exchange. This is a max number, up to 24. 28% of all ways that we see at the XP, they have some sort of prepending. It's very difficult to be elected the best way. Access provider that is connected to XP. It's funny, and there is no way to do it. Up to 80% of all guys, they filter anything at XP. I have 4 prefixes and I'm not returning one. No, I'm not returning to anyone. So they just filter everything they get from XP. And up to 34% of XP, they are not return any traffic back. This is their maximum number, the average 34. So according to the type of XP, they will not get anything back. Fine, what can we do? Well, we thought about some alternatives. One of them, to be more informative. We are able to measure each one of the XPs as to the three metrics: XP coverage, customers' preferences in comparison to other XPs. I'm connected in São Paulo and Porto Alegre, and I want to talk to Cloudflare or any other one. If I want to get the traffic in Porto Alegre, I'm not gonna get that if I'm in São Paulo, right? That is the interrelationship among XPs. And last, traffic asymmetry. If I'm connected in Amsterdam or Porto Alegre, some networks will prefer to deliver in Amsterdam, whereas other in Porto Alegre. Who are they? You may have two Brazilian ASs, but they prefer to give back the traffic throughout the American provider. Or to change the service model. This is another possibility. They may base symmetry on flow. They can have a label and say that this is a network which I'm pretty sure that is asymmetric, low latency. This is the difference between this type of measurement in comparison to remote peering, because remote peering I just measure in the router, and here I have all symmetric networks. And third, standardization. There is a demand of a large provider, NCAST draft, requesting to identify the CDN networks and NCAST. This is a Cloudflare proposal. Or a range of ASs to CDNs or to NCAST networks which behave differently, where we should have a router model different from others. Usually they are guys, delivering content. Today, the effort of the CDNs, they are done by themselves without any additional effort. These guys, I will receive traffic from here, preferably, or just let them decide whatever is best. What have we done? We have developed a visualization platform, but that's a project, that's a minimally feasible product, where we have a weak database, and we are able to check in each one of them their point of view. They just have to download the Power BI and to check results. That's it. Time is up.
Boa. Tá aí então os contatos do Leandro.
Well done.
Leandro, eu tenho uma questão aqui que veio pela...
There is a question, Leandro, from the chat.
Eu tenho uma questão aqui que veio pelo chat do YouTube, que é o seguinte, do Gilberto Davi.
Gilberto Davi is asking. The analyses were excellent. But there is a question, maybe due to equipment from different companies, shouldn't they use unknown routes or non-homologated routes? Yeah, I'm saying that because Brazil is full of surprises.
Eu vou dizer que dentro do Brasil, se tu considerar esses 5 que a gente analisou, ele não é o
If you consider those 5 agents, they are not the worst case scenario. In my last presentation, there is a link with a paper with more additional results. So Brazil is not doing so bad. We are not the worst. You're gonna find worse cases than those.
Bom dia. Primeiramente, parabéns.
First of all, congratulations. My name is Andrea from Sage. What has drawn my attention was those 20% of prepending, where the prepending was applied by the IX participant as to the downstreams.
Ele prependava os downstreams, mas não prependava ele mesmo. Isso. Aí me veio à cabeça se isso poderia ser não o participante fazendo isso, mas sim uma...
Could be the participant doing that. Or I don't know if that can be a setup error, but the participant, no, I mean the downstream, if there is a community to that participant who would influence prepending, as they could participate directly with some sort of redundancy. I'm going to send that block to my traffic provider who participates at the IX, and so am I. So I'm going to send the prepending on one side, but not on the opposite side. Have you considered all the ATM hot server routes or just the selected ones? If you are talking about the filtered guys, no. We have connected to the ATM and then we connected to the data source, what they would send us. I'm getting the end product of the route server. So we would be working on best routing, yes. Let's say that that specific participant had some issues, and then the prepending. We are analyzing symmetries. Why are you sending me traffic? We are sending traffic through XP. Well, depends. Well, they are sending traffic by themselves, so the asymmetry was the origin. This is a methodology which we have developed. There was no need to check the methodology because I was getting the packages directly to a server which was connected to the IX. I have a server, I upload a BGP session, and you know, that was exactly what we did. Asymmetry. Well, we still have one final question, and you know, it's lunchtime. But my concern has to do with RTT. Would there be an asymmetry, but that would be very close, one participant to another? Well, we did not get into details to measure all of that. That was not our main emphasis. We have just measured to those guys that were totally, you know, outliers, where we performed the RTT analysis, but not the whole RTT exploration. Data is there. Okay, thank you. Thanks a lot, Bertoldo. Now it's lunch time, and we shall be back at 2 p.m. Thank you.